We are rolling. Okay, good. We're doing great time-wise. There are 3 ways for Algebra 1. You are going to... Did I do that wrong?
No, your Y is backwards, that's what I said.
Where?
Under system.
On systems, the Y is backwards.
Oh, yeah.
Well,
You can still do it.
Thank you. Okay. There are many ways to solve anything in math, right? There's many ways. Everything can be solved in different ways, right? I'm teaching you 3 ways this year and next year. I mean, it's the same thing. To solve systems of equations, to find that point where those 2 lines meet, right? I'm giving you 3 different methods. So there's 3 ways to solve them, 3 ways. The first way is you can solve by graphing, right?
yes.
And we figured out that graphing is not bad and it's not hard as long as it goes right on a grid point, right? It's like as long as it's right on exactly over 2 and up 3 or something like that. But if it's over 2 1/3, up 3 and 3.471392116, right? It gets really confusing. You can't tell me what the point is. I mean, if you do, you're lucky. I mean, if you actually get it right, you're lucky, right? So you have to have another method, which is algebra. You have to use algebra. And so the other method we learned was substitution. And all of you guys are quite proficient in that now. You're really getting it. The third method is called elimination. And sometimes this is easier, sometimes this is easier. Kind of depends. Now, there's 3 useful ways to write equations. What are they?
Graphing.
To write equations. You got the slope, intercept, which is y equals mx plus b. And then you have, what's another one? Point slope, which is y.
minus y.
Plus equals x, just parentheses, x minus x1.
Good, yes, all right. Y minus y1 equals m times parentheses x minus x1 parentheses, right? Point slope. The third one is called what again?
Oh,
Standard form.
Standard form. What is this in? Standard form. You have x and y on the same side of the equal sign, right?
Yes.
So they're both in that. Now, if we were using substitution, we would have to manipulate, right? Right? We'd have to choose one of these, and it would be. Look at it for a second, though. Look at it. If I used substitution, I could manipulate. But notice, if I solve for x, I would eventually have to divide 2 into 11. Will that give me a whole number? No. I wouldn't want it. I don't really want to be dealing with fractions, right? Like substituting a fraction into another equation. But if I divide 11 by 3, I could solve for y. Oh, but that doesn't come out with an even number either.
No.
Oh, well then I'll try this one. I'll manipulate this one. I could divide 13 by -2, and of course I'd get a fraction again, right? That's not so good. I don't want that. Oh, but I could divide 5 into 13 and solve for y. But then that gives me 13/5, right? So I would have, any way I tried substitution, it would be a nightmare, right? Don't you agree with me?
Yeah.
You'd end up having to solve, you'd have to put something, 3/2, x is equal to, or y is equal to 2/3, -2/3 x plus 11/3. And you'd have to substitute that in and solve for it. Not an easy thing to do, right? I mean, you could do it. I could do it. You could do it. But it would just take a while, right? There's this other method called elimination that, for some problems, are like make them easier than easy. Easier than what you did last night. Like way easier, right? Anybody have an idea? Look at those 2. What do you see? Just look at them. Do you see anything that looks interesting?
-2x and 2x.
Oh, tell me more. Ooh, right on. So what could we do, what do you think we could do with these two equations to actually eliminate the x's?
Add 2x to
Divide.
2x.
Not divide. Say it again. Who said add? What were you going to say? So say more.
2x to negative 2x and just cancel each other out.
Wait, so if we do that, then we'd have to add the whole equation to the other equation, right? Don't you? Because we got to do the same thing to everything, right? Let's try that. Let's try that. Let's just draw a line and let's put a plus sign right here. We're going to add these two equations together. This is so cool. To be honest with you, I'll just tell you, I shouldn't say this on a video. This is magical. I honestly, for some reason, my brain, I cannot understand why this works. And Nate can get it. He's tried to explain it to me. It just goes right over my head. And it's okay, because it's magic. I don't know. I just love that math can be magical, right? It's not just logical. It's also magical. This is magical. Watch this. This is so cool. You're going to love this. Watch this. If I add them together, what happens to the x's? They cross out. I don't have any x's. So what do I have? 3y's plus 5y's is 8y's equals 11 plus 13? 24. Oh my gosh. We're one step away from finding out what y is. Do you realize how easy this is? Divide by 8, divide by 8. Y is equal to 3. Oh my gosh. Look how fast that was. That was a two-step solution. You know what I mean? That was like so easy. Now I gotta find my x, right? So I choose either of my two equations. I don't like this one because it has a negative 2x in it, personally. I just choose my easiest equation, right? Sometimes they all have negatives, so I just use them. But if there's not a negative, there's less potential for error, right? So if you're doing a test, for me, it would be better to choose the one with no negatives, because the negatives seems to be where people often screw up. So I'm going to choose this one. I'm going to rewrite this equation. 2x plus 3y equals 11. And I am going to substitute 3 in for y. So that is now going to become a 3. So I'm just going to do it. 2x plus 3 times 3 equals 11. You with me? You writing this down? Make sure you have all this written down, because this is going to be homework tonight. You're going to have to do this. So now that gives me 2x plus 9 equals 11. Oh, this is pretty easy. What do I do now?
Minus 9.
Minus 9 minus 9, right? Oh my gosh, look at this. 2x is equal to 2. Divide by 2, x is equal to 1. And our answer is 1, 3. And we did something that if you use substitution would have taken you 10 minutes. But using elimination took you 30 seconds. You know what I'm saying? Yes. That is so simple, so easy. Do you see the difference? Do you see how? So basically, and there's going to be a few. There's going to be a few lectures, a few classes where we talk about these and go further in elimination and understand how to use elimination. Because I'm giving you the simplest ones right now, right? The simplest ones have a positive 2x and a negative 2x. Or it might have a positive 3y and a negative 3y. Or it might have, you know what I'm saying? They're going to match up, right? So I'm being nice to you. That's the homework tonight. It's going to be very easy and enjoyable, okay? And I can give it to you now. So that's it. Are there any questions? That's it. That's it on the lecture. So.